Welcome to the channel. The problem is sinusoidal voltage having a peak value of Vp is an input to the following circuit in which the DC voltage is Vb. Problem is given on diode. This is the symbol of diode. This terminal is anode. This terminal is cathode. The input voltage is positive and which is above the forward voltage drop, say Vf, then diode will be in on state starting conduction. And if the voltage at anode is negative, diode will be in off state and there is no conduction of current. So these are the basics. Forward biasing of diode and reverse biasing of diode. I mean to say, if the input voltage is positive at the anode terminal, diode will be in forward biasing. If the input voltage is negative, diode will be in reverse biasing. The basics of diode and its forward biasing, reverse biasing. Also about the cut-in voltage. I explained in previous videos. I am providing the link in the description box. In this case, the diode with bias voltage, DC bias voltage Vb is given. The voltage drop of diode is Vf, DC bias voltage is Vb. In this case, if the Vd, that is total voltage, will be Vf plus Vb, if the voltage at anode is above Vt, then diode will be in on state starting conduction. Here the diode with DC bias voltage is given and we have to find out the nature of output waveform. The condition I told to start the conduction is if the input voltage, sinusoidal positive input voltage at anode, it goes above the total voltage, which is forward voltage drop plus DC bias voltage, the diode will be on state. In the problem, the current limiting resistor is given R, diode, forward voltage drop is Vf, and the DC bias Vb given. We have to find out the nature of output voltage. In this case, if the input voltage which goes above the total voltage, this is nothing but Vf plus Vb, diode starts conduction. So in this case, if the input voltage at anode is above Vt, which is nothing but the summation of Vf plus Vb, diode starts conduction. And if diode will be in on state, maximum current will flow through this path and this is short circuited and no voltage drop across this terminal. Second case, if the voltage at anode, which is below Vt, diode will be in off state and we are getting the maximum voltage drop across these terminals. Diode will be in reverse biasing, open circuited, and we are getting the maximum voltage drop across the output terminals. Nature of the output sinusoidal signal will be like this. This is Vt. We know that Vt is equal to Vf plus Vb. So at this voltage, diode will start conduction and there is no voltage drop above this in voltage. The diode will start conduction, and above VT we are not getting the output voltage, and below VT diode will be in reverse biasing, and we are getting the maximum voltage drop across the output terminals. So nature of the output signal, which means that this part will be clipped off, and this type of circuit is nothing but clipper circuit. And here the positive part of sinusoidal signal is clipped off, and that is why this circuit is called as positive voltage clipper. And this will be the nature of output waveform of this circuit, and this is the solution. Thank you.